Hello everyone, welcome to our lesson. Let's continue with our lessons. Right, what are we going to look at today? We are going to look at Euclidean geometry activity 2, simple activities. Remember, we haven't started looking at the past examination past examination papers now. We're just looking at each theorem and applied. And then later, we're going to look at examination questions where we're going to be um, looking at all the theorems and how the examination questions are structured. Okay, right now we're still on center theorems. Let's continue. Remember to subscribe to our channel and make sure that you view our videos. Okay, right now, O is the center of the circle. Calculate the value of x. So now I'm going to be giving you a short time. Maybe this one need 1 minute. It's not. It's very easy. Right, 1 minute, and then after 1 minute, I'll just give you the answer. Let's try. You should be done by now. What did you get? So x is an angle that is subtended by which arc? Can you see the arc? I can see it here. This is arc AC. I can see this arc. So x is subtended where? At the circumference. And then O2 is subtended where by that arc? At the center. So it means x is half of O2. So therefore, x, only x is equals to 30 degrees. Don't forget to write the reason. Don't forget. So it's angle at center equals 2 times angle at circumference. Okay, right, done. We're going to the next one. We're going to be fast on this one because it's easy questions. Right, let's try this one. Another minute. Well done. What did you get? Did you get 48? That's it. Yes. So these angles are subtended by the arc AB. We can see the arc AB there. Okay, x is at the center and then 24 is at the circumference. So x is 2 times 24. So it means x is equals to 48 degrees, y angle at center equals 2 times angle at circumference. Okay, done. Easy questions. Right, now let's go to the next one. Another minute. What is the value of x? Can you try it for a minute? I hope you managed to get it. Can you see that these are angles? There's an angle subtended at the center and this circumference. Okay, let me show you. Let me try with this one. This is arc AB, right? You see that AB? And then the angle is subtended where? At the center, which is x. Okay, which is x. And then there's an angle subtended where? At the circumference. Let me use a different color. Right, a different color. So we have this one here. You see, this one is subtended where? By the same arc at the circumference. So 10. So 10 is at the circumference, and what? And x is at the center. So it means x is going to be 20 degrees. So x is equals to 20 degrees. Angle at the center equals 2 times angle at the circumference. Am I right? I think so. Yes. Right. Okay. Now, when you're looking at the angle at the center, I want you to check for these 3 types of diagrams. Okay. There is a clear one. I will say this one is a very clear one. Okay. I'll just write the shape without naming the vertices. Okay. This is the center. So we have an angle subtended at the center there. And then the one subtended where? At the circumference. So I'll use 2 lines for the center one because it's double. And then 1 line there. Okay. And then you have another one which is like this. You look out for these diagrams. It's like a bow tie. You know a bow tie, right? It's like this one. This is the angle at the center here, subtended by this arc. And then this is the angle at the circumference. You see that? looks like a bow tie. You see that? And then this is the center here. Okay, which is this one here, the one that we just talked about here. And then there's another one which looks like a cyclic quad. You know a cyclic quad? But remember, cyclic quad, all the vertices must touch the circumference. But this one vertex is touching the center, not the circumference. So it will be like this, and then like this, and then like this. Okay, so you look out for these diagrams. So there's this angle, and then going with this angle. You see that? This angle going with this angle. So sometimes you recognize these angles. I know that the angles must be on the same side of the lines. So like this angle is below the lines. So here also we're talking about below the lines. When I'm talking about the lines, it's these ones, okay? So here is below the lines. This one is below the lines. This one is below the lines here. It's below the lines. Okay, let me show you something if maybe I give an idea. You see this one? Let me draw it like this. I'll draw the one with which is like a cyclic quad. And then they may sort of maintain the same side, the angle at the center and the angle at the circumference. This one is to the right of the lines, and then this angle also will be to the right of the lines. Do you see that? Okay, yeah, continue. Give another one. Let's say it's like this. This is the center. So this is the arc, okay, at the center, and then the circumference. This angle is to the left of the lines. This one is to the left of the lines, something like that. So you must come up with your own way of remembering how you can identify these angles, okay? Right, so now remember the three diagrams, okay, when you talk about the angle at the center. Right, now let's move on to the next question. Right, how many minutes here? 1 minute is enough. Let's try. What is x? Can you try to find x? Right, well done. Let's do it together. So there is arc AB here, or BA. This arc here. It subtends this angle at the center. You see that, which is 36. And then it subtends this other angle here at the circumference. The arc AB subtends the angle at the circumference. So it means x is half of 36. So it means x is equals to 18 degrees. Why is x equal to 18 degrees? Angle at the center equals 2 times angle at the circumference. Okay, right, perfect. I think this one we have managed to understand it now. Let's see if we're going to get something different. Okay, is it different? No, it's not different. Let's find the value of x here. How many minutes? Still 1 minute. You don't need to do a lot of calculations here. 1 minute is fine. Let's try. Right, okay. Well done. What did you do? Did you get 240 for x? Yes, it should be 240. Now the arc we're talking about is the major arc, the big one. Do you see? The big one. This is the big arc which is subtending the angle at the center, not the smaller arc. So this angle here should be, the x is 2 times this angle here. So it means here x should be 240. You see that? Okay, that's the one which I was talking about. It looks like a cyclic quad, but remember, cyclic quad, all the vertices must touch what? Must touch the corners of, sorry, the corners of the quadrilateral must touch the circumference, like this one here, which I'm just extending here. Okay, right. So now we're saying x is equals to 240 degrees because angle at the center, angle at the center is equal to 2 times angle at the circumference. Okay, so don't forget that every time I'm writing a reason, because it's a must. It's a must that I write a statement and a reason, so I cannot skip that. Now, let's try this one. What is it? What is x here? How many minutes? Let's see. I think give you time. 1 minute again. 1 minute. Let's try. Right, okay. Let's see what it get. What is half of 230? So this is the angle we're talking about. It's at the circumference. This one is at the center. It's subtended by the big arc, the major arc AC. You see that this major arc AC here. So this one is at the center. This one at the circumference. Do you see they're maintaining this same side? Okay, above the lines here. Do you see that? So it means x is 115. x is equals to 115 degrees, 115 degrees, y, angle at the center equals 2 times angle at the circumference. Okay, right, done. Now, can you try this one? Let me see. 3 minutes. 3 minutes is too much. Maybe 2 minutes is fine. Okay, can you try to find the value of x here for 3 minutes? Right, sometimes mark allocation will guide you in the examinations, okay? If you see that the mark allocation is a bit higher, then means you have to do some steps, okay? Because I can see here people will be tempted to say what? To say that x is 75 degrees, okay? But x is not 75 degrees here because you see, we should be talking about this angle and this angle. So angle O1 is 2 times x, not angle O2. No, O2 is not 2 times x. It is O1 that is 2 times x. Remember that, okay? Like I said, we're maintaining the sign. These angles are on the left of the line. So, okay, we're talking about O1 and x. So we need to find angle O1 first before we do anything, okay? Right, so now we'll say what? We'll say, what is, okay, let's do this. O1, angle O1 plus angle O2 is equal to what? Angle O1 plus angle O2 is equal to what? It is equals to 360 degrees. Why? Because its angles around a point. Okay, or you can say angles in a revolution. It's fine. Now we have O2 here, so it's going to be O1 plus 150 degrees is equal to 360 degrees. Then subtract 150 from both sides of the equation, or transpose minus 150 degrees. So it becomes O1 is equals to 210 degrees. Right, what is half of 210? So it means therefore x is going to be 105 degrees. Y, angle at the center equals 2 times angle at the circumference. At the circumference, okay? My writing is becoming clumsy now, but it's fine. Let me try. Okay, so now we have managed to find x there, and then are we done? We're supposed to find x. Yes, we're done. We're done this. We're supposed to find x. Done. Let's move on to the next part. Now, I want you to find the value of x and y. So you find the value of x, and then after that, you find the value of y. I know here some of you already know the properties or opposite interior angles of a cyclic quad. You can use that, it's fine. Okay, I'll give you the alternative methods, but we're still concentrating on the center theorems. We haven't done the cyclic quad theorems, okay? But if you know how to use it, it's fine, you can use it. But I'll show you how you get the same answer from the two methods. Let's try. For how many minutes? Let me give you 4 minutes. Let's try. Right, welcome back, learners. Did you manage to get x? Right, what will be the value of x? X will be half of 95 here, because this angle subtended by arc BD at the center, and then x is the angle subtended by BD at the circumference. So we can say that x is equals to 47.5 degrees. Why? Because angle at the center equals 2 times angle at circumference. Okay, just angle at center, even without this. Just angle at center equals 2 times angle at circumference. It's fine. And then now we have, this is 47. Let's write this because we're going to need this for our next question. Right, it's 47.5. Right, now, those who know how to use the cyclic quad, they can say that angle x plus angle y is equals to 180 degrees. Let me just use another color for that, so that when you come back to our center theorems, we'll see that we're getting the same answer. Right, let me just write it here by this side here. So we're saying angle x plus angle y is equal to 180 degrees. So the interior angles, the opposite interior angles of a cyclic quad are supplementary. They add up to 180 degrees. So you say the reason here, opposite angles of a cyclic quad. That's the reason you write. Opposite angles of cyclic quad. Okay, right. And then you say 47,5 degrees plus y is equal to 180 degrees. And then say y is equals to 180 degrees minus 47,5 degrees. And then y is equals to 132,5 degrees. Do you see that? And then let's go back to our center theorems and see if we're going to get the same answer. Right, now I'm going to get O1 first. O1. And then after getting O1, then we can get Y. Okay, so what is O1? So O1, we say O1 plus O2 is equals to 360 degrees. Why? Angles around a point, right? Or angles in revolution, right? So O1 plus O2 is equal to 360 degrees, but we have O2, so it's going to be O1 plus 95 degrees is equal to 360 degrees. And then we subtract 95 degrees from both sides of the equation. What do we get? 95, and then we're getting 265. So this is only O1, sorry. Angle O1 is 265 degrees. And then, now, so this one is 265 degrees, this one. Okay. And then y is going to be half of 265 because it's an angle subtended at the circumference by the big arc BD. Okay, let me try to draw this. This is the big arc BD, which is subtending angle O1 at the center and angle y at the circumference. So O1 is 2 times y. Okay, so now how do we get y? We divide by 265 by 2. So y is going to be 132,5. You can multiply this and see if you're going to get 265. Okay, right. This should be 264. Yes, you get 265. So because angle at center equals 2 times angle at circumference. Okay, done. So we've managed to find y there, and then we're done. We found our x, we found our y. Right, let's do the next one. Oh, we've done everything. We found x and y. So let's just leave this one. We're going to the next one. Right, O is the center of the circle. We're almost done. I think we're after this one, there's one more. And then Q2 is 70 degrees. Calculate the value of x and y. Let's try this. I'm going to give you 4 minutes. Let's try. Right, welcome back. So now we need to find the value of x and y. So what do we do here? What do we do? We've been doing questions like this. Even in activity 1, we did a question like this. So if we check here, we have O1. Let me see. Okay, I have to use my pen here. Okay, I don't have it. So let's use my pen. Let's see if I, okay. Okay, it's fine. Let's use my pen. So O1, OP and OQ here are equal. Why are they equal? OP is equal to OQ because they are radii. Okay, you see that? So now OP is equal to OQ because they are radii. And then we can say that P2 and Q2 are equal. So P2, angle P2 is equal to angle Q2. Why? They are equal because these are angles opposite equal sides, since OP is equals to OQ. Okay, right. So it means if this is 70, this is also 70 degrees. Okay, this is also 70 degrees. Then we can find our x here, which is this part. Okay, so now we can say this 70 degrees plus x here must give us 180 degrees. So let me just use the value straight away. So 70 degrees plus 70 degrees. Okay, P2 plus P1, Q1. P2 plus Q2, sorry, P2 plus Q2 plus O1, and then which is X is equal to 180 degrees. Why? Because this is angle sum in triangle. Right, you see that? And then this is 140 degrees plus X is equal to 180 degrees. Okay, what is 180 minus 140? We can do this without the calculator. It should be 40 degrees. So it means X is 40 degrees. Okay, right, done. And then what would be Y? If O1 is, or X is 40 degrees, Y is going to be 20 degrees because they are subtended by the same arc here, PQ. Okay, X is at the center, Y at the circumference. So therefore, Y is equal to 20 degrees. Why? Because angle at center equals 2 times angle at circumference. Okay, right, you see that, you can do that. And then, so this is 20 degrees. We have solved for X and Y. Done. Okay, let's move on to the next one. We've done both angles X and Y. Now let's try this one. I'm going to give you how many minutes? 2 minutes to do this one. It's easy. It's easy. Please take note of the information that you're given there. That must guide you. Let's try. Right, welcome back, learners. So what do you see here? Because the information is very important. Today I didn't read information a lot, but there are things that we must check. Always the center, we're talking about center theorems there. RP parallel to OQ there. When you see R parallel, what do you think of? You must think of the alternate angles, corresponding angles, and co-interior angles. Alternate angles are what? Are equal. Corresponding angles are what? Are equal. Co-interior angles are supplementary. Okay, so let me just show you alternate angles. They say these are parallel lines. This is a parallel line. So it will be like this. They form a Z or even an N. You see, they say these are parallel lines. These are parallel lines. They will form a shape like this. So it can be N in any orientation. Okay. And then corresponding angles, look for the F. They are something like this. Okay. In any orientation, these will be parallel lines. Okay. See that? So it can be even like this. Let's say any orientation, but it forms an F. They say these are parallel lines. You see that? So these are corresponding angles. How do you see corresponding angles? They're on the same side of the transversal. The transversal is the line that cuts the parallel lines. They are on the same side of the transversal and also on the same side of what? Of the parallel lines. That is corresponding. And then alternate angles, they alternate, they change the size of the transversal, and they are also they are between the parallel lines. Okay, that's alternate. And then co-interior, the angles are between the parallel lines, okay, but on the same side of the transversal. Then these are supplementary. Okay, right now, if we check here with our parallel lines RP and OQ. So let's see here, 20 is what? It is alternate to O1. So we can say angle P here is equals to angle O1. Why? Because alternate angles equal. Why? Okay, because OQ is parallel to RP. You see that? Alternate angles equal, OQ is parallel to RP. And then it means this angle is what? Is 20 degrees. So therefore, O1 is equals to 20 degrees. And then O1 is subtended by PQ at the center. You see that? Is subtended by PQ at the center, and then X is subtended by PQ at the circumference. So it means X is equals to 10 degrees. Y angle at center equals 2 times angle at circumference. Okay, done. So we've managed to solve our equation, sorry, not solve for X and Y, and we're going to continue with our activities on what? On the center theorems before we go to the tangent theorems. Let's meet in our next lesson. Thank you very much for joining us.